Alright, so I'm going to be covering how to graph sets on a number line, as well as writing the interval notation that also represents a set. Alright, so without further delay, let's get to it. Alright, so our learning objectives for this lesson are to plot points and inequalities accurately on number lines, to understand that using open circles for values not included will be these symbols, the greater than and less than sign without the bar under them, and using closed circles for values that include the numbers for the greater than and equal to signs and less than equal to signs. And then shade the correct direction to show all possible values that satisfy the condition. So here's what our worksheet would look like. And without further ado, let's jump right into it. All right, so for graphing inequalities, first thing you're going to need to know is that the inequality symbol, if it's going towards the x, then that's going to mean that it is greater than whatever number that is. You can think of the inequality symbol as like an alligator mouth, as I once learned. The mouth always goes towards the side that is bigger. So we read left to right, so we'll say x, and then we'll identify, is the inequality sign going towards x or away from x? Again, if it's going towards x, then x is greater than -4. If it's going away from x, then x is less than 5 in this example. And then when you include the bar underneath, then that means that it can also be equal to the value that was presented here. So, for example, x is greater than or equal to -4. So in this example, we're going to go to -4 on our number line. -1, 2, 3. That's a mistake right there. -4. And then because we have the bar under than the greater than sign, again, the inequality symbol is going towards x. So x is greater than -4 or equal to, we're going to use the closed circle. So x can be -4, but it can also be any value that is greater than -4. So we shade towards the direction of all the numbers that are greater than -4, and it's going infinitely in that direction. All right, and then next, we're going to look at number 2, where x is, again, the inequality symbol is going away from x, so x is less than the value of 2, which means when we go to +2 on our number line, we are going to use an open circle, and then we're going to shade towards the direction of all the numbers that are less than that 2. So x are all the numbers less than 2. I'll leave numbers 3 and 4 for you to practice. So that's how you graph an inequality. So let's level up that skill 1 or 2 more steps where we're graphing the set of all x values that satisfy both inequalities. So let's decode this first before we attempt to graph, because this is very similar to the first skill we just practiced. And in this example, right, the XER just represents that the value of x, its element, right, its characteristics are real numbers. So real numbers include, whole number, counting numbers like 1, 2, 3, whole numbers including 0, negative integers like -3, -4, and fractions and decimals. All of those numbers fall under the real numbers category. All right, again, the element, so x's element is all real numbers. The next thing we need to know is that this is broken down into 2 inequalities. So we have x, the symbol going toward x, x is greater than -2, and we have x is less than or equal to 3. And the symbol in between them, we need to know what that means. So this symbol simply looks like the A in the word and. It does mean and. If we look down at number 7, right, we have the opposite symbol, which is of course going to be opposite of and, which is or. So and means that the value of x has to include both properties, both criteria. So x has to be any number that's greater than -2, and it has to be less than or equal to 3. So let's go ahead and graph that to see what that looks like. So we're going to go to our number line. Let's start with our first inequality in blue. X is greater than -2. There's no bar under the greater than sign, so we're going to use an open circle. And we're going to shade towards the direction of the numbers greater than -2. However, it's not going to go towards infinity because we also have a second criteria, which is the second inequality here. And for the second inequality, I'll number those 1 and 2. X is less than 3, so I'm going to go over to number 3. Or equal to 3, so I'm going to use a closed circle and then shade towards all the numbers less than -3. And we can see that this graphs both inequalities on the number line. So here we have x is greater than -2. Let me write the number -2 here. So it's going towards the direction of all the numbers greater than -2. However, because it says and right here, it also has to be less than or equal to 3. So all of these numbers represent the values of x, describes that set. So x could be 1, 0, or -1, 0, 1, 2, or 3. And actually, because it says real numbers, it could also include things like 2.5 would also be a value of x. So have you ever seen a question that gave you this graph of the set and asked you, hey, could 2.5 be a value of x? Even though you don't see that number on the number line, or 1.5 or -1.5, right? That value actually would be included in that set. All right, let's look at number 7. I'll leave number 6 for you to practice on your own. Again, it's with the and symbol. For question number 7, the difference here is you have the or symbol, so it could be either or for these inequalities. So all the possible numbers or values of x that are less than or equal to 5, or it could be all of the numbers for x that are greater than or equal to -4. So let me color code these. I'll use purple for the first inequality. I'll use green for the second. All right, so let's start. And remember, x's element includes real numbers. So it includes fractions, decimals. But that part's really not important for graphing, but it is important for recognizing which numbers are included in what is being graphed. So x is less than 5. I'm going to go to 5. So 1, 2, 3, 4, 5's here. Or equal to 5. So because there's the bar under the inequality, less than or equal to, there'll be a closed circle. And I'm actually going to write this sort of on the bottom so you can see which direction this is going. And x includes all the numbers less than 5. Now, for the second inequality, x is greater than or equal to -4. I'll go to -4, so -1, -2, -3, -4. And because it has the bar under the inequality symbol, it can include that value -4. And x can be all the numbers greater than that -4. So now we're going infinitely in this direction for all the values greater than -4. And that is how you will graph that set on a number line. Again, try number 6 on your own. Now, the next thing you're going to do is interval notation, which is another representation of sets. So it basically explains what's on the number line, but in a shorter version. So, things you need to know. Interval notation is simply another way to describe a set of real numbers. The same way a number line is a way to describe a set of real numbers. The parentheses means the endpoint is not included. So, parentheses essentially are like your less than or greater than signs without the number being included. So those would be your open circles. While on the other hand, your brackets represent your less than or equal to, greater than or equal to signs, and that will include a closed circle. Close and open. The open circle, open circle. All right, here are some examples. So for the inequality, x is greater than 3. You see there is a parentheses for the 3 because the 3 is not included. So x is greater than that. So going towards the right is infinity, because though there are infinite numbers greater than 3. However, you cannot include infinity. So just all the numbers leading towards infinity. Infinity is not a number that can be included, so there's a parentheses here. For the example number 2, we have x is less than or equal to -2. So again, we have that or equal to, so we're going to use a closed bracket. And for the -2, and notice because x is less than -2, we actually have a negative infinity because there are infinite numbers less than -2, and they do go towards the left side of the number line, which is why the negative infinity is on the left. And again, there's a parentheses because infinity or negative infinity cannot be included. And now if we combine those two examples, we get our third, where we're graphing two inequalities at once. So now x, we'll start with x, and x is in between two numbers and two symbols. X is greater than, because the alligator mouth is going towards x, greater than 2, and x is less than, because the alligator mouth is going away from x, or equal to 5. So here we see the parentheses for 2 because it's not equal to 2, and we see the bracket next to the 5 because x can equal to less than or equal to 5. And here's descriptions of those interval notations. So it's between 2 and 5, but not including 5. Less than or equal to -2 for here, greater than 3. So now moving to question 1, it says all real numbers greater than or equal to -2. So this looks like pretty similar to example number 2 here. So let's try to find the pattern. So all real numbers is going to include x. And x is going to be greater than, we can actually write our inequality, x is going to be greater than or equal to -2. So because it can be equal to -2, I'll go to -2. I'm going to put my closed circle, and x is all the numbers greater than or equal to -2, so I'm shading towards the direction of all the numbers larger in value than -2. So now I have my part A, my number line, my part B, my inequality. Now for the interval notation, again, we're going to have two values that we can show here. One is the -2, which is included because of the bar, so we can put the parentheses. And 2, it's going up in value, so it's going towards infinity, but not including infinity, so we will put the parentheses. And that's all there is to interval notation. Whether you're using interval notation, inequalities, to graph multiple numbers, or number lines, all three of these examples, all three parts of this problem, are essentially the same or different ways of saying the same thing, different ways of representing the same sets of numbers. and sometimes those numbers do lead to infinite numbers, so you cannot write down infinite numbers. So this notation is a way to represent, to express multiple or potentially infinite numbers in a short-handed way that's more clear, more concise, and more efficient. Right, interval notation is probably the most efficient that you can get. Definitely more efficient than writing it on number line. So I'll leave number 2 blank for you to practice with. Make sure you're using examples from above. You're checking your circles. You're checking your parentheses and your brackets, if it's including the equal to sign. And I hope this helped. Happy studying. I look forward to the success on your Unit 1 quiz. Mr. G, signing off.